Okay, today is going to be a little bit different. We are going to be making the Dishonored teleport system. And the way this is going to go, this is probably going to be a much longer video. We're going to make the actual teleport system in like 10 minutes. And then all the extra stuff, so like how it registers when to go on top of something versus teleport into the air, being able to teleport onto a ledge like this, despite not being able to see it. All that stuff we're going to do later, which is going to take probably close to an hour. And then we might make the mana pickup and the mana bar if we have time. But that is what we're going to do. So let's get started. We're going to make this in Unreal 4.27. And we're just going to make it in the first person template. Okay. First person. And this is going to be, we're just going to call it the Blink tutorial. Okay. So I'm going to start. I'm just going to clean up this scene a little bit. And then we're also going to add some modifications, or we'll do that in a bit. We won't do that yet. So for the first person, just if we just wanted to teleport, we can get rid of, we're going to get rid of all the gun stuff. And we don't need, we're not using a controller, we're not using VR. So we can actually move all of that. Okay. Okay, so just so we have a clean template here, we'll just call this movement. Just like that. And on fire, which is going to be the first mouse button, we want to create a, we can actually delete all these, and we'll want to create a, so we'll call this blink checking. And we'll just set this, and when this is on, it goes on. When this is off, and then the actual thing we're going to do is going to be on tick. Which is going to be right here. And we're going to, it's not called raycast, line trace by channel. And we're going to get the first person camera. Just going to get the location. We can get the world location. Forward vector. We're going to multiply this by a float, and let's say 1800. And then we're just going to add these here. This will go in the end, the start will just be the actual location like that. And this is just creating a vector that goes out from the camera. 1800 units. Turn this on for now. And then we're going to break this. We actually don't care if it hits or not, because we're going to get the trace end location, and we're going to promote this to a variable. And then we're going to set location actor right there. Teleport. Look at that. So let's see what this does. So this is going all the time though. Forgot to throw in the blink checking. There we go. So now, as soon as I start holding it down, it will be, and then it will move me. So there you go, teleport, right? Easy. But you notice if it doesn't recognize like edges, right? Let's turn this off real quick. So let's also get rid of this here. Even if we're not going to use it, I want it to at least, we might use it later, so I'm just going to keep it centered, which this is -8 because this is 16, so we want it to be in center. So that's blink. We did that in like 5 minutes. So now we're going to do everything else, which I think is going to take close to an hour. Okay, so we have this. Let's add some complexity. So the first thing we're going to do here, okay, and we're going to actually be making a function. We're going to call this function set teleport point. And if you notice, let me pull up the demo here again. Okay, so you notice in this demo, when I hold it out, there's a shape at where I'm going to teleport. And just for the sake of simplicity, it's a circle if it's just in space. So if I just want to teleport into space, it's a circle. If it's on the ground, I have it be a cylinder. Okay? And then if I'm going up, if it's like finding an edge and putting me on top of the ledge, it's a triangle. Or if I'm going straight into a wall, it's a square. You can obviously make those shapes whatever you want. I took inspiration from Dishonored, of course. They have a bit more fancy graphics, but broadly that's the system they use. Where when it's on the ground, it's a cylinder. When it's a wall, I think their wall one's actually different. When it's an edge, it's kind of this little arrow. They have their arrow actually on the edge. I put it at the teleport point. And then when it's in the air, they have kind of a circular graphic. Okay, so that's what we're going to set up. So we need a way to tell which type of teleport. So I'm going to add, I just make a folder called custom art whenever I'm messing around. And we're going to make an enum. So this one in particular is going to be called blink type E. And there's going to be 4 different blink types as we've shown. So the first blink type is going to be, we're just going to call this edge. The next blink type we're going to call floor. This one we're going to call floating, which will just be in the air. And then this one will be a wall, like that. In the first person character, we're going to blink types E, and we're going to call this blink typed E right there. can pull this into here. We're also going to need an array that has all the different teleport points, the types of geo. So we'll call this teleport point geo, just like that. But this one is going to be a static mesh, like that. But it's going to be an array. So let's go ahead and compile this, and we'll add 4 different array, and we're going to just link these up with this in the same order that these are. So we'll do the edge, the floor, the floating, and wall. So if you all recall, that's going to be the cone, that's going to be the cylinder. I don't think that's the right one. Let me pull out this one. We want this cylinder. There we go. I'm gonna do the same with the sphere since there's a ton of spheres. We want this one though. We want the generic one. And then the cube. There we go. So now we have those different points. And what we're gonna do here is we're gonna do select, and then we're going to get a copy of this. And we're just going to list this out. This is going to be 1, 2, 3. 0, 1, 2, and 3. So depending on what this is set to, it will select the right piece of geo. For ultimately, we're gonna have 4 different kind of options depending on what is actually happening here. Or it's going to do 4 different things in this function. The main thing it's going to do, and let's actually make a teleport point. Or that's what it's going to, we're just going to be a cube. Like that. And it doesn't matter what this is for now. We're going to turn off all the collision, and we're going to make it not visible for now, since we will turn it visible when we use it. But let's drag this in here and set the world location like that. And we can set that to teleport. It doesn't actually matter since the teleport is more of a physics function, but it's not going to hurt anything. So it's not like it won't teleport if we don't have that set. Okay, we're just going to route this down since we're going to use this for a few other things. Okay, and then the other 3 things, we're going to need some conditions. So we're just going to link these up. Just like that. So for the first one here, we need to set the static mesh. We only want to set this if it's actually not what it's supposed to be. So what we'll do is we'll get the actual teleport point. We'll get the static mesh. Get, let's see, there you go, get static mesh. And then we'll say if this does not equal this, then go ahead and set it to what it needs to be. Because there's no point in just setting it again and again if it's already set correctly. So that's what that's for. But if it's not set correctly, we can do set static mesh, and we can just grab whatever is going to be here. Like that. Give myself a bit more space. so those don't. Okay. For the second one, we want to turn the visibility on. So once again, no reason to set the visibility again and again if it's already visible. So let's just do, hey, is this not, if this isn't visible, set it to be visible. Because if it already is visible, who cares? It's all good. We don't need to set it again. So we'll set visibility and we'll make it visible. We'll propagate to children. It's not going to matter here, but if you had like effects, you could parent them under there or things like that. Or if your geometry was a bit more complex, the propagate is going to be a good thing to turn on. And then the last thing, and we're going to need to create a new variable here. We're going to call this blink point. And we're going to set this. This is just going to be a vector. And we're actually going to set this to what is getting fed in right here. Once again, we're going to do equals, and as long as this is not equal to the blink point, then let's set the blink point. The blink point is a variable we'll use later. Actually, that's pretty similar to how we're using this one, but we'll clean it up later. And this is what we need. This is the only function we're going to need, but there's going to be a lot, since we're going to be using this in a few different spots, I think. But let's see if it works. So let's get it hooked up. So the actual set teleport point, let's see if we can just, okay. We are going to, oh, not this, we're just gonna drag this here just to test it. So we're gonna do this, this, and then in terms of trace and, let's see here. Oh. We do also need to set this. So we'll set this to something. We'll just do floating as default, just to set it. I am actually, let's do select here. Select the vector. If this doesn't hit anything, then this. However, if not, let's just get the location it actually hits. So that way we don't go through walls and stuff as easily. Okay, let's see what this does. So you can see we have a point and it's gonna take us to that point. Granted, this is always visible, so we would want to turn it off. I can delete these. So we would want to turn it off when we're not trying to blink, which we'll just do that here. Let's just grab it out of this function. And we'll turn that off. Not actually turning off. Probably because this happens the same frame here. Let's see. Something is oh, no, teleport point, set visibility. I think this is happening in the wrong order, so to speak. So let me test this again. Okay, it gets turned on, it doesn't get turned off though. I wonder if we put another, hey, only do this if we're still checking. I wonder if that would matter. Nope. We will figure out why that's not turning off correctly, actually. Oh, because we don't actually turn off blink checking. Pretty obvious. There we go. Okay, so this, you see the little point. I'm also, while we're here, since we're kind of building up features, we are going to go ahead and add in a piece of UI. So we're going to add a user interface. We'll just call this the player HUD. And this is where we'll add the mana eventually. But for now, we're just going to add a crosshair. And we'll just put that in the center of the screen. 1 second. And we'll just make that 2 pixels. It's going to be this little white dot. Seems like a itty bitty thing. But it actually works pretty well for a crosshair. So here on begin play, and we're just going to get the controller, and then we're going to create widget. There we go. I guess we need that get controller. We need to get the player controller. This is going to be mana stuff later. Okay, let's throw in the player HUD here. We actually want a reference to this. Like that. And we'll add it to the viewport. Like that. So you see we got a little dot, and it's not a bad teleport system if this is all you want, but it doesn't handle like trying to get up here. I could overshoot it and then like fall, but it's not as smooth as you would want it to be. So let's actually add in some geo here to give us some better testing grounds so we can really build out this system. So we're gonna add like a platform here, and then we're gonna add something with like a ledge. Like that. Which is something that I think our current system is going to do quite poorly. It's actually not too bad. So again, you could make that work if that's all you wanted, but as is a lot of things in game design, the first section is fairly simple, and it's all the little refinements that really take time. So we're going to take time today and actually implement those refinements. So now we need to figure out, how can we know what to actually set here? We're just setting it as the floating one by default. But like, what can we actually check when we play the game to know if it's a wall or if it's the floor or if it's an edge? And as you may guess, the main way we're going to do this is by ray casting. So we're going to do a series of ray casting, and we're going to do a few different checks. So let's actually make a sequence here. And the first one is going to be very similar, just the starting one. So we're actually going to keep all of this here. And if we don't hit anything, this one's an easy one. We know for sure, so we'll just do a standard check here. Hey, if we hit nothing, then we can say we're for sure floating. Because in both, the other three circumstances where we're on the floor, but where we're on the floor, we're on the wall, or we're on an edge, the initial ray cast will at least hit something. So that one we can be fairly certain of. Like, if we don't hit anything, just use the trace then location and leave it at that. That's all we need. However, if we hit something, and we're going to call this initial cast location, and we'll relabel this too. We'll just call it point. Not very descriptive, but okay. Then get the actual location, because there's most likely we don't actually want to teleport there when we hit something, but we are at least going to want to know where it is. Okay. After that, though, let's actually, that's fine. We need to do another line trace, or we're actually going to do a sphere trace. And we're going to do a few of these depending. So the first one we are going to check is this the floor? Which is actually a fairly simple thing to check. So we're going to come off of this one, and we're going to say, we're going to do a sphere trace. By channel. And the way we're going to do this, we're going to do it in such a way that regardless of the actual height or sphere, it knows it will adapt, so we don't have to hard code it based on the exact shape of our character. So we're actually going to grab the capsule component a few times, and we're going to want the capsule radius. This one right here, get capsule radius. We're going to get the capsule half height, this one down here. And then we're going to get the radius again for something else. The first thing we're going to do is we're going to get the capsule radius, and we're going to, we want to check just a little bit more than the capsule radius. We're just going to add 1 to that. We don't need much. And then we're going to multiply this by a vector, and we're just going to get the up vector. We don't need the actor up vector, we need the just overall up vector, the up vector of the world. So, and then we're going to take this and we're going to add it to our initial cast location. Which is just going to be vector plus vector like this. And that is going to be our start location. For our ending location, for the actual radius of the sphere, we can fill that in right there, which is going to be the capsule half. Oh, not the capsule half height. The capsule radius, of course. And for this though, the capsule half height, this is, as the name implies, it's half. We want the full height. And we want to subtract this by the radius. The reason we're subtracting this is it actually factors in where the, I'm trying to figure out how to explain it. When it's calculating a radius, let's say, let's turn on snapping. So this is the start point. And then if it goes up 500 units, you notice the actual ending of the sphere is slightly more than 500 units away because the sphere itself has a radius. So we want this to end at 500 units spot on. So in order to actually end at that 500 unit mark, we need to not go 500 units, we need to go one radius less than 500 units. And that actually ends at where we want to end it, which is what we're going to do. So that's why we subtract the radius from this. And then we're going to need the up vector again, since we're going to multiply this by float. And then we're going to add these in order to get the ending location here. Okay. So what this will do, I wonder if we can actually visualize it. Let's see that. So this should visualize when we hit something. Let's see if this shows up. There we go. So all this does is when we hit something, it's just going to put a virtual player, so to speak, in the same spot we're looking. So you notice that it gives us a different input when we're on a wall, but when we're on the floor, it's not going to hit anything since it's a bit above the floor, 1 unit above the floor. And then when we are on a wall, it will know since it actually hits something. So we can pretty reasonably know for sure if this does not hit anything, then we can set, so let's make a branch here. If we do not hit anything, we can pretty reasonably set this to be the floor. And then we can bring in the teleport, set teleport point. And for the actual blink, let's use the blink look point. And then this teleport point, we are going to grab the capsule half height multiplied by the up vector. Sorry, I'm obsessed with copy and paste. And we are just going to add the initial cast location. Because without this, here, let's just leave this to the initial cast location. And I'll show you why we want this. Otherwise, we'd get that. And we don't actually want to teleport, because remember, what we're teleporting is we're teleporting the center of the player. And when we are hitting the floor, we don't actually want to teleport the center of the player to that point. We want to teleport it a bit, the capsule half height up. We want to teleport the player's feet to that point. So that's why we hook it up like that. So now you can, let's see if we may have messed something up here. Teleport point, capsule half height, up vector. Initial cast location. Let's see what's going on here. Set teleport point. Blink point. The blink point's not actually getting set. So let's check here. Yeah. There we go. There we go. So to see, even if we go into the floor, it doesn't actually teleport us through the floor, since it's smart enough to throw us above the floor, which is what we want. Okay. So we found a way to test for the floor. We found a way to test for the air. So we only have two more edge cases. We want to know if we're on a wall or if we're on a ledge. So we're going to do that next. So how do we test if we're on a wall? Well, the way we're going to do that, and let's turn this off, is we're going to use another sphere trace. And this seems expensive, which sphere traces are fairly cheap, but remember, we're also checking every time. So we're only checking doing the next sphere trace if the first one is not working. So just like last time, this one will be, it's going to be the capsule radius here, but the methodology is going to be slightly different. So we're going to need the capsule half height and the capsule radius again, this and this, and this, and this. And for this one, let's see, I'm gonna hook this up. Plus initial cast location. This one's actually gonna go into both, since we actually just want like a sphere to appear. And I'll show you why we're going to do this in a second. So I'll show you what it does. So you notice on the wall, it's checking here. Let's see if we can illustrate it a bit better. it's checking to see if it hits. So this kind of knows if is the ledge itself empty. And it will, because we already kind of know if it's not the floor, then it's going to be a wall. But the edge case we're trying to test is literally an edge, right? Like, is there a ledge above the wall? That's what we're testing for. So that's why we're putting the same thing in both components, because we really just want to sphere trace a distance above to say, hey, is the height above, if we one player height above the point of the wall, is that empty? And if it is empty, then we are going to know it's an edge. So once again, we're going to do the same stuff down here. We're going to grab the teleport point and we're going to say, okay, if this hits something, we know there's not a ledge up there. So we can confidently say it's going to be a wall. However, let's also break this. If it doesn't hit something, we're pretty sure it's going to be a ledge, in which case we want to go on top of the ledge. Okay, this one, let me set up we're actually going to add 3 different vectors here. We were going to add the initial cast location. We're going to add the normal. And then we're going to add the up vector in the same way we do down here. This is actually, this is kind of to fix another edge case here. So the reason we're doing the weird math here, I'll show you. It's particularly, we're adding the initial cast location with the height of the player, but we also moving them slightly away from the wall because we don't want them just to clip into the wall. So this particularly becomes apparent. Let's see if it messes up here. If when you're in a corner, there, I think you can, even with this system, there is a way to mess it up. Another version to do this is to do the capsule, let's see, a capsule radius like this, and then move that away from the wall, because you notice that way. Here, let me actually turn off this. I think that should be okay. Or here, let me. I think I can do hidden in game. Yeah, there we go. So you can't actually see it at all. Yeah, good. So you notice this will be like away from the wall better if I actually move it a full half radius. Or is it? Why is it not? Capsule half radius, vector up. Oh, because it's displaying this one here. I guess we can keep this in. Like that. So this is farther away from the wall. Here you can kind of see it. It's not a full, the cube is still clipping, but you notice it is staying away from the wall. But I found if in corners you can, there's a few situations where if you move the person away from the normal too much, it will, you can kind of like teleport you into a wall. So to avoid that, I just move them one normal away instead of the full capsule radius away. Okay, let's keep moving though. So for then the one here, we actually still have one more check. Both examples are going to be edges, but they're going to be different types of edges. This one though, we're going to do a line trace. So we're going to do line trace by channel. And this is going to be if it's not a wall. We know for sure it's not a wall. We know it's not the floor. We know it's not in the air. But we want to figure out what type of edge is it? And where do we actually want to place the character when they're on the edge? So then we're going to do get the actual actor up vector is going to matter here. Or it might actually not. We're going to get the capsule half radius multiplied, and then we're going to multiply this by a float like this. So we're going to do, okay, let's grab the initial location. We know it's an edge. Let's go up by a certain amount. And then, but we kind of want to place them into the edge relative to however they're, so if I'm looking at this edge, I pretty reasonably can guess that I want to go toward in the direction of the camera into the edge like that. So that's why we're grabbing the camera vector. We are going to multiply this by a float, which is just going to be the capsule radius divided by 2. And the only reason we're doing that is we want the player to be pushed onto the edge one capsule radius. So if it was just half radius, the player would be put like exactly on the edge, and we want to push them fully onto the edge. So that's why we're doubling that. We actually going to break this though, and then remake it, because we actually only want the X and the Y here. We don't actually care about the Z, because how much the player is looking up or down doesn't matter to us. We're going to add this here. And this is going to be our start location. And then our end location is going to be fairly simple to calculate. We are just going to add this vector with this vector here, and that will be our end location. And I will show you what this does. Okay. Okay. So you notice it's going up top and it's checking. Is that area above the edge Like, where's the actual floor if you go above the edge and then trace down? Because that's what we want to know. So the actual break here, these are both going to be the edge. So this one's going to be the edge, and then this one's also going to be the edge. I'll keep key bindings off. I am using, to grab it, that's control. In case you want to know what that shortcut is. Another cool one that took me a while to learn is you hold down control and shift, you can actually grab a pin and move it to something else. Like, kind of cool. Okay. And we're gonna set the teleport point for both of these, but the actual point that is gonna go here is gonna be different. We're gonna do break the hit result. So this one is going to be the up vector. It's going to be similar to this one. Yep. We're just going to add in the location here. Vector plus vector. So this is like, hey, if you actually hit something and you know where the floor is relative to the edge, go ahead and go up a little bit from that relative to how much the player is, because once again, same thing as the floor. If this is our player, we don't actually want the player there, we want the player there. So the point that we need to put the player is going to be half the capsule height. So that's what we're going to do for this one. Just like that. And then the one down here is, hey, if you don't actually hit something, don't take the hit location, but take wherever this ends. And just use that point instead. And the use case for this is, what if, like, you have a fence or something, oops, or something that doesn't actually have an edge or like something to stand on, in which case just throw me on the other side. You don't need to try to perch me. You could make this more exact if you, again, there's all the refinements are the things that take time, so you could easily find ways to justify to do this differently. So like that's just going on the other side versus this doing it like that. So kind of up to you, but that's the way I set up mine. You could use a selector here as well, or like this. Let's actually, I might leave this and then just do one of these. Yeah, this is an option as well. I'm gonna leave it though. I'm just gonna leave this as an option. That's messy. But this is a learning project, so in the same way, you know, could use as well. Make myself little notes to learn from. This is probably a better way to do it, actually. So that way you don't need the branch here, and you need to duplicate all these. And in the same way, could use, let's give us some space. so this is all the teleport logic. So it's close to an hour. We're going to do all the refinements. Use this if you want the player from the wall. Okay, so that's the teleport logic. Let's do some fun stuff. So we are going to set up the material on our teleport point, which is a fairly simple material. We just kind of, let's do it here. I'm gonna call this M rotating. Like that. This is just a translucent material. It's unlit since it's kind of a UI element. We're gonna make it two-sided. This is gonna be transparent. We're gonna make some panners. Oops. Like that. We're gonna need a texture sample. And we're just gonna grab any, Unreal has a bunch of noise textures by default. Which one do I want? I want the noise offset. There we go. Offset noise distance. Plug these into the UI. And we're going to make these texture coordinates, and we're just going to make these slightly different. So we're going to do 0.9. Since we don't want the scale to be hugely different, but we don't want them to line up perfectly either. And then we'll just make this 1.1. Like that. And then the speeds will make opposite. So this one will be -1. This one will be 1. Like that. And we're just going to multiply these together. This is the color. We're going to give it a mana-y color, some blue. Mana's always blue, apparently. We're going to multiply this for the emissive color, and then this will go straight into the opacity. Like that. And we get kind of that effect. And we're gonna slap this onto the teleport point. Let's see if this actually works. There we go. And there we go. So this is a bit more refined on the actual system. Kind of crazy how much small refinements take. Like, we just made it a little bit smarter. We were able to make the actual teleport system in 5 minutes, and then it took most of the hour to make the rest of the system. If you want to know how to make the mana pickups, feel free to mention it. Or if you want to know how to make the UI bits where it acts like Dishonored, where it recharges unless you use it while it's recharging, up in the top left right there, and then it can recharge. If you want to know any of that stuff, I can make a follow-up video. This is a little bit different style, but I'll see you all later.